major part of factoring. Greatest common factor is the first thing you're going to look for every time. So, with factoring, I like to go ahead and give you the most complicated problem you're going to get. So, sometimes I have to write these down to... Let me get a good problem here. Okay. All right. So, this is going to be our first example, and also we're going to write down the instructions as we do this one. So, factor completely. And we are going to have 12x to the third plus 26x squared minus, yes, this is the problem, minus 56. Is that right? Yeah, 56x. Alright, and as we do this problem, we're also going to write down the steps for doing all of these problems. So the first thing you always do is factor out the greatest common factor or I'll mostly call that the GCF if there is one. Now we will do a lot of problems that do not have a greatest common factor, and so you will forget this step probably. But I have started here with a problem where we do have a greatest common factor. Okay, so if I'm looking at this, Riley, what would our greatest common factor be for this expression? 12x to the third plus 26x squared minus 56x. What could we divide all those terms by? What? 12x. 12 is not going to go into 26 or 56. So we're going to have to go smaller than that. 4 won't go into 26. 2 is going to work. I don't think 3 goes into 26. So I think 2 might be our lowest. And when you're unsure, go ahead and divide everything by 2. And then if you see you can still divide by more, you know you should have picked a bigger number. But so we can divide by 2, and we can take out an x as well. So we're going to have our 2x out front. And so when we divide everything by 2x, Riley, what will we get on the inside of the parentheses? So whenever we divide everything by 2x, what will we get right here? Okay, we'll have 6. How many x's with it? Good. And our numbers get a little bit big here. Okay, 13 x 56 negative 28. Okay, so greatest common factor is your first term every time. Now I'm starting with, normally whenever we learn something new, I start with the easiest problem that we're going to do, and we work our way up to the hardest problem. For these notes, when I teach factoring, I always start with the hardest problem we're going to have, and then we work our way back down to easier ones. So this is as difficult as it would possibly get. So you've got pretty big numbers. You got to think a little bit. You might even have to go over here to the other side and do some long division for that 56 5 by 2, 2 goes into 5 twice, 2 times 2 is 4, subtract 1, bring down 6, 2 goes into 16, 8 times, so you got 28. So you might even have to do that a little bit if you don't remember off the top of your head. Okay? And you might get this without a calculator, so be prepared. I won't go much bigger than this, but I would expect you to be able to do this. Also, another key to this is you have to know your multiplication tables, because if you don't know your multiplication tables pretty well, you're going to have a hard time with factoring. A really hard time. And you'll see why here in a second. All right, so the second thing that you're going to do, okay, is you're going to list multiples or factors. Which one? I guess factors. Factors, not multiples. Sorry. Get my terms mixed up. List factors of the first and last term of the trinomial. Trinomial means how many terms? 3. Okay? I don't think so. I looked at doing that. I thought about teaching you guys that way this time. But it's a trick. And I don't think it's going to help us. I don't think it's going to be any easier than the other way that I have taught it in the past. I have seen kids use it before, yes. Yeah. It works. It's real easy on the easy problems. It's not much easier and possibly even harder on the harder problems. So, but the easy problems are easy this way too. But I don't like to start with them, because if I only teach how to do the easy ones first, then nobody can ever do the hard ones. If we start with the hard ones and work our way back, then usually you kind of like figure out tricks for those easier ones. And you can also do the harder ones too. Okay, so, all right, so what we're doing here is we're looking at the trinomial only. This 2x, it's going to just kind of sit out front. We're not going to do anything with it. So the trinomial only, we're going to look at the first term. So our first term is 6x squared. Okay? And we're also going to look at our last term, which is negative 28. Okay? And so we are going to think of numbers that we could multiply to get 6x squared, or terms. 6x squared. Yeah, 6x squared. Sorry, I'm running out of room there. So our first term is 6x squared. So what could I multiply together to get 6x squared? 2x and 3x. Okay. What about something else that would work? There's another one. We could do 6x squared times 1, although I will tell you, Tristan, except for in very rare instances, our best bet is to always split our x's. So instead of doing like an x squared on one and just a 1 on the other, let's do a 6x and a 1x. So there's some very rare instances where you might want to put the square just with one of them, but usually we do not. So it's best to split. We also could do negative 2x times negative 3x and negative 6x times negative 1x, but the negatives are usually best. Don't deal with them here. It's better if you deal with them over on the last term. So typically, most cases, you want to go positive here. All right, we okay with those? There's nothing else we can multiply together to get 6x squared, right? Okay, so negative 28. To get negative 28, what could I multiply together? Negative 4 and 7, or I could do positive 4 and negative 7. What else? 14 and 2, so I could do negative 14 and positive 2, or I could do positive 14 and negative 2. There's one more. What else can I multiply to get 28? No. Oh, I heard it. 28 times 1. 28 times 1. One of those need to be negative. That made it look like a 7. So that one, you can always use 1 times the number. So sometimes we forget about that. Or we could do negative 28 times 1. Okay, so alright, so the 2x, it stays out front. What we're going to do is we're going to split this into 2 binomials. Alright, and so our third step right here. You don't have your math teachers tell you to do this very often, but guess and check. Usually, we try to give you strategies so you don't have to guess and check, right? You pretty much have to guess and check on these. Okay? And so let me show you what I mean by guess and check. Alright, so we're going to pick one of these. We could do the 2x times 3x or the 6x times x. I will tell you, it is generally, probably, it is more likely that you will get the two that are closer to each other. Sometimes you get the others. It just depends. But I usually start with the ones that are closer to each other. So 2x and 3x. Those are going to be your first terms in each binomial. And so that comes from the first over here. So I'm trying 2x and 3x. And then over here for the last terms, I'm going to pick one of these. I think I will go with, I'm going to do this positive 4, negative 7 right here. So I'm going to check positive 4, negative 7. Those are my two last terms. And so we have guessed a possibility, and now we are going to check to see if it's right. Okay? It's a dangerous day to be writing in pen, though, Evan. Did you find your pencil? Today is a dangerous day to be writing in pen. Be prepared to mark out a lot if you're writing in pen. Because anytime you're guessing and checking, things are not going to go well for you. We're not doing it. If you already know how to do it, you're welcome to use it. If you already know how to do it, you're welcome to use it, but you need to be able to do it on all of the problems, and I don't think it's going to help us that much. Sometimes I've found, like, I have taught things multiple ways, and sometimes that confuses kids more. They need just one way. The better you are at math, the more strategies you have, and that is good. But we're going to stick with this one. I had considered that. If you already know how to do it that way, you're welcome to use it. But I'm going to go with my way. So, alright, so, if I check this, 2x times 3x is 6x squared. I already knew that because I picked factors that would give me 6x squared, right? Then, for our middle terms, I do 2x times negative 7. That would give me negative 14x. And then I would do 4x times 3x, which would give me positive 12x. And then my last term's negative 4 times negative 7, and positive 4 times negative 7, that gives me negative 28. I already knew that because I picked numbers that would give me negative 28, right? So what we're doing is we're picking numbers we know will give us 6x squared, and we know will give us negative 28, kind of like you guys were doing on that worksheet we were doing. And then we're guessing and checking to see what works in the middle here. So this, if I combine negative 14x and positive 12x, that gives me negative 2x. Is that what I'm supposed to get right here in the middle of this trinomial? No, I was supposed to get 13, right? If I multiply these two back, it should give me what's here, which means I should have 13 in the middle. So because this is 6x squared, minus 2x minus 28. First term is correct, last term is correct, but the middle term is not right. So that tells me this doesn't work, I'm wrong. Right here, yes. Alright, so what I just tried did not work. So since what I just tried did not work, I'm going to have to try something else. So this is why it's dangerous if you're writing in pen today. Now, before I try different numbers, especially when you got a number right here, a 2x and a 3x, it might work if we just switch where they're at. So before I try different numbers, I'm just going to switch the 4 and the 7. So I would have a minus 7 right here and a plus 4 right here. Okay? And so if I check here, are you guys okay if I don't write this part down? 2x times 3x is 6x squared. We knew that was going to be the case because we picked numbers that would give us 6x squared. And then so I'm going to do 2x times 4, which is going to give me positive 8x. And I'll do negative 7 times negative 7 times positive 3, which will give me negative 21x. And then I'm not going to write this part down, but negative 7 times positive 4 would give me the negative 28 right here. Okay, if you're not paying attention right now, you are not going to figure out how to do this on your own. Okay, please pay close attention. This is not that easy to do. All right, so if I combine these two middle terms, what do I get? 8 and negative 21. Okay, negative 13x. Is that what I'm supposed to have? No, but is it really close? All right, I'm supposed to have a positive 13 in the middle right here. Okay, so this is if you ever get to this point, if you've almost got it, if your sign is the only problem, you can fix it by changing the signs of these two numbers right here. So instead of what do we have? We had negative 7 and positive 4. Let's make it positive 7 and negative 4. Okay, so we're going to change our signs. And if we do that, 2x times negative 4 is negative 8x. And positive 7 times positive 3 is positive 21. And now, negative 8 times plus positive 21 gives us positive 13. So, we have found 2x times 2x plus 7 times 3x minus 4 is our answer. Okay, it is your answer because it multiplies back to give you what we started with. Okay, questions? Yes. Say that again. Sorry, I couldn't hear you. Okay, so what I'm doing is I'm distributing here, just like if I were multiplying the whole thing together. So I didn't write this part down, but I might should. 2x times 3x gives us 6x squared, right? And then 2x times negative 4 gives us the negative 8x that I have right here. And then 7 times 3x gives us positive 21x. And then the positive 7 times the negative 4 gives me the negative 28. So when I combine those two middle terms, I would get 6x squared plus 13x minus 28, which is what I had before I started to factor, so I know I factored correctly. Okay, now we started with the most difficult problem we could possibly start with. So we're going to do some more of these. If you have some questions still, we're going to do more, okay? So don't become overwhelmed because we're going to do more practice. If you don't understand this one. On the quiz Wednesday, yes. Look. Julie. You haven't even tried it on your own yet? You might, yeah, it's 3 whole steps. And we are going to practice those all week. So, yes, and then we'll review for tests. So yes. Wednesday's a quiz. Quizzes are to let me know who's got it, who does not. Usually there's a good number of you that do. That has happened before, Tristan. All right, let me give you another good one. I got to make sure I get a good one here. Okay, let's do 4x to the third plus 9x squared plus 5x. Okay. All right. So our first step always is to look for a greatest common factor. Okay. So, Connor, what can our greatest common factor be for this one, or do we have one? Okay, you do not have a number. Could you take an x? You could, because every term has an x with it, right? So how many x's could we take out? What's our lowest exponent on our x? It's a 1 right here, right? So we're just going to take out a single x, and that is going to leave us on the inside with 4x squared plus 9x plus 5. Okay, so once we take out the greatest common factor, it just kind of sits out here. We're not messing with it anymore. This stuff in the inside, that trinomial, is what we're factoring. Okay? All right, so our first term is 4x squared. Our last term is positive 5. Okay, so, Cole, what could I multiply together to get 4x squared? 2x and 2x. Okay, and what else? There's something else I could multiply together to get 4x squared. 4x times 1x. Very good. Okay, so those are my options for my first terms. I can't use anything else because anything else would not give me 4x squared. All right, and then, Gabe, what can I multiply to get 5? Let's only go whole numbers. That's it. Now, you should like to see this when that happens because it means there's less options that you got to guess and check. We actually didn't do too bad on the last problem because only having to change it like 3 times was probably pretty good on one that difficult. All right. So there is an infinite amount of ways to get 5 without whole numbers. You're correct. We want to factor with whole numbers for this. So I should be more specific. Now, there is one other way to get 5 with whole numbers. We could switch. We could do 5 times 1 instead of 1 times 5. But I'm thinking about...
negative 5 times negative 1.
Yes.
Commutative property says it's the same thing, though.
Okay. Commutative property says it's the same thing if we switch them, but not if we make them negative. Okay. So, now, however, do you see any negatives in this problem anywhere? So it's probably unlikely that we're going to use those negatives. All right. Because although it would give us a positive 5, there's no way we're going to get a positive 9 in the middle if we do that. So the x, it just hangs out front. We're going to have 2 sets of parentheses. Okay. Aiden, which one do you want to try for the first? 2x and 2x or 4x and x? 4x and x. And then Aiden, we really only have one option that seems viable here for the 5 is the 5 and 1. Which one do you want to put first? The plus 5 and then the plus 1, or the plus 1 and then the plus 5? 1 and then 5, so plus 1 plus 5. The only reason I'm doing it this way is because Aiden told me to. Okay? We're just guessing and checking. Okay? And there really is not, especially when you have a coefficient in front of that x squared, there's not a foolproof way to do this easily. Okay? So you just kind of have to guess and check. So, Aiden, we are going to multiply these two back together to see if we get 4x squared plus 9x plus 5. So tell me what to do there, Aiden, to multiply these two back together. Okay, what does that give us? Very good. And then, okay, what's that give us? X, right? Okay, now, I'm supposed to get 4x squared plus 9x plus 5. Does that give me 4x squared plus 9x plus 5? No, because those middle terms right there are going to give me 21x. So, this is not right. Now, this may look a little different to you than I did last time because I multiplied that whole thing out. I'm afraid it might confuse you if I'm skipping steps. You don't necessarily have to check the first and last because you know you picked the right ones there. I usually don't, but this did not work. So since this did not work, I need to try different numbers. Or, what else did I tell you we need to do? Not change the signs, because we were not that close. We didn't have, but switch the numbers. Let's try putting the 5 right here and the 1 right here. So before you give up on the 4x and the 1x and the 5 and the 1, you need to switch where the numbers are at, because maybe it will work if we just switch where they're at. Okay? So, Aiden, tell me how to multiply it together now. Good. Good. Very good. Oh, Aiden, is this going to work? It works because 4x and 5x is 9x, which we're supposed to get in the middle. So make sure you know what the answer here is. The answer is this factored part. The answer is x times 4x plus 5 times x plus 1. Yes. Keep it. Okay. All right. Questions? Why do I put the parentheses here? Down here? These parentheses? Because you're multiplying those binomials together. So, like, if you're wanting to check to see if this is right, you would distribute here, and you would get this, and then you still have this x right here. You distribute that, and that's going to give you 4x to the third plus 9x plus 5x. Okay, questions? All right, let's do another one. We need lots of practice with these. All right, let's see. All right, let's do 3x squared minus 11x plus 8. Okay, it is prime as far as the greatest common factor goes. You cannot get a greatest common factor out of this, right? And several of the problems, in fact, probably most of the problems you're going to see, like on tonight's homework, are going to not have a greatest common factor. Okay, so no greatest common factor. So we're going to go straight to our first and our last. So first is 3x squared, and our last is positive 8. Okay, so Riley, what could I multiply together to get 3x squared? 3x times 1x. And that is pretty much our only option for that, right? We could switch it. We could be x times 3x, but no other numbers are going to work, right? And then, Tristan, what could I get to for my last term, that positive 8? 4 times 2. Okay, I like that Julie's saying negative 4 times negative 2. What makes you think we might need that negative? I've got that negative and 11 in the middle, so I bet we're going to need the negatives here. What else could I multiply? 1 times 8. And negative 1 times negative 8. And I think that's everything for this as far as whole numbers go. We've already got 2 times 4. Well, the order you can switch. Yeah. All right, so I always like it whenever I've only got one option for my first term. So 3x and x has to work. It's the only way it can work. I bet we're going to need some negatives because if we don't put any negatives, there's no way we can get a negative 11x there. So, Julie, which ones do you want to try? The negative 4 and negative 2 or the negative 1 and negative 8? Okay, so negative 4, negative 2. Alright, so if we multiply this back to check, 3 times x is 3x squared. If you want to skip writing that, that's fine because we knew it was supposed to be that. Then we would do 3x times negative 2, which gives us negative 6x. We'll do negative 4 times x, so negative 4x. And then negative 4 times negative 2, which gives us positive 8. If you want to skip writing that, that's fine because you got the positive 8 over here. Now, is this going to give us negative 11 in the middle, Julie? No. Okay, before I give up on 4 and 2, what should I try? Let's switch where they're at. Okay, so, what did I have here? What did I have? I have 4, so I need 2 here and 4 here. Okay, so first term's 3x times x is still 3x squared. Then I will get a negative 12x. I'll get a negative 2x. I still get a positive 8 on the end. And that gives me a negative 14 in the middle. That's a good idea. Let's try that. Negative 1 and negative 8. Alright. Negative 1 and negative 8. Let's try that. Because we're giving up on negative 4 and negative 2. Alright, so I've got 3x times x is 3x squared. I've got 3x times negative 8 is negative 24x. You think it's going to work? I think that's going to be too big. Negative x plus 8. Oh, it didn't work. Before we give up on this, what have we got to do? Switch 8 and 1. That's going to change our middle terms. Alright, 3x times x is 3x squared. 3x times negative 1 is negative 3x. 8 times x, negative 8 times x is negative 8x. Negative 8 times negative 1 is positive 8. Does this one work? Yes, so our answer is 3x minus 8 times x minus 1. Now, sometimes you get lucky and you pick the right one right away. And that's wonderful. And then sometimes you try and keep picking the wrong ones. And it takes forever to do these problems. Okay. All right. We're going to do one more problem. One more problem. All right. Okay, let's try this. 2x squared plus, 7x minus 30. All right, first term. 2x squared. It is prime as far as our GCF, right? Nothing we can take out. First term, 2x squared. What can I multiply to get 2x squared, Adam? 2x times 1x, right? That's the only option for this. So I could go ahead. I know I'm going to have a 2x and an x right here in my parentheses. It's my only option. My last term is negative 30. So what do you guys think? Negative 15 times 2. Or we could switch to negative, right? I'm not going to write it, but we can switch to negative. Negative 1 times 30. Negative 3 times 10. Negative 6 and 5. Yep, I think that's everything except for we could switch to negatives, but I'm not going to write that because it just makes it long. Okay? All right, so, Evan, which one do you want to try first? All right, Evan picks negative 6 and 5 because we're running out of time. Okay? All right, so if we check it, 2x times x is 2x squared. 2x times positive 5 is 10x. Negative 6 times x is negative 6x. Do I even need to keep going? Is that going to work? That's not going to work. Let's switch the 5 and 6. Put the 5 here, the 6 here. Okay? Do not pack up. Alright, 2x times x is 2x squared. 2x times 6 is positive 12x. Negative 5 times x is negative 5x. Negative 5 times 6 is negative 30. Does that one work? Yes, so 2x minus 5 times x plus 6 is our answer. Now, I kind of gave Evan a hint because we were running out of time there.